Two satellites S1 and S2 are moving in the same orbit. The masses of S1 is 4 times the mass of S2, which of the following statement is true. First one, it is given that the potential energies of Earth and satellite in the two cases are equal. As we know that potential energy depends upon the value of mass. So if I am just writing the equation for potential energy, it is going to be minus of g mm divided by orbital radius. As the masses of satellite in both the situations are not same, mass of S1 is 4 times the mass of S2, so mass is different and definitely potential energy will be different, so the first option is wrong. And S1 and S2 are moving with the equal speed. Yes, we can say that this orbital velocity is root of gm divided by r naught, which is not depends upon the mass of satellite, so orbital velocity will be same. Kinetic energies of two satellites are equal. We know that kinetic energy is also depends upon the mass of satellite. The equation for kinetic energy is half into g into mm divided by r naught, so we can say it also depends upon the mass, so which is not going to be same. The time period of S1 is 4 times that of S2. Their time period will be same. Time period is not depends upon the value of its mass, because time period or square of time period is directly proportional to cube of radius. It depends upon the orbital radius, not depends upon mass, so it will be same. So here it is given that 4 times, so that is also wrong. Only B option is correct.